Here we are discussing measuration. We have the ways of measuring our shapes. Shapes are measured using their dimensions. So we have what we are considering today is the two-dimensional shapes, and they are called plane shapes. Plane shapes. And the first shape we are going to be considering today is our triangle. Triangle is a two-dimensional shape, and this triangle A, B, C. In a triangle, angle A, angle A is facing this side, that side A. Angle B is facing this side, that side B. Angle C is facing this side and that side C. And normally the height of a triangle is the perpendicular height. And the base of that triangle will be determined by that perpendicular line is forming angle 90 degree, like you have it here, angle 90. So automatically our base for this triangle is A. Formula for finding perimeter. These are two ways by which you can measure plane shapes. Perimeter, which is moving around an object, and area, which is the space occupied by that shape or by that object. So for perimeter of a triangle, you have side 1 plus side 2 plus side 3. Side 1 plus side 2 plus side 3. Look at it now. Side A plus side B plus side C. And that's the perimeter of a triangle. But the area of a triangle, like we're all familiar with, is half base times height. I said earlier that the base of this triangle is where the perpendicular line is forming angle 90 degrees. And here the base here is A. So that's why we have it as half A times I. So I don't want students to always believe that the base must be B. The base must be B. So the base of any triangle will be determined by that particular line where angle A, the perpendicular line is forming. Another way for doing that, which you have said earlier, is when you look at the triangle that we have already, looking at that triangle, we can substitute for H using our trig ratio. And that's, look at it now, the opposites. This is a hypotenuse, so we can use sine theta equals to H over C, which is opposite divided by the hypotenuse. Substituting that, H now, making H solve the formula will give us sine theta times C, which is C sine theta. And if C sine theta is then substituted for the value of height here, we have it as half AC sine theta, half AC sine theta, given to you also. And this formula is mostly used when you cannot find the height, you don't know the height, and the angle, an inclusive angle is given. Because if you go back now, you see the inclusive angle. You can see that this is the inclusive angle. That's the angle between A and C. In between A and C is called an inclusive angle. Another formula is square root of x into x minus A, square root of B minus B, square root of square root of x into x minus A bracket, x minus B bracket, x minus C bracket, where x is the semi-perimeter. We made mention of the perimeter the last time as side 1 plus side 2 plus side 3. That's A plus B plus C. Now, semi means half divided by 2. So when you substitute that, you can also have the area of a triangle. The next shape we are considering now is our rectangle. A rectangle. The rectangle is have the length and the breadth, the two opposite sides are equal. And you see B is equal to B. That's why you have that line to show that this line are equal. So that means this side is L, this side will also be L. This side is B, this side will also be B. And every rectangle has angle 90 degrees. That's the four 90 degree. So how do we move around the object? Perimeter, like we said, is moving around the object. That's length plus breadth plus length plus breadth. You can see that length plus breadth plus length plus breadth. Length plus length. So when you collect the light times 2L plus 2 breadth, which factorization 2 into bracket L plus B. The area is length and breadth LB. The next shape we are considering now is our square. A square for a square, all the sizes are equal, side x. So we can represent x, some we represent with L, but we decided to represent ours with x. Can you see? And the 90 degree, they will have that. Then perimeter moving around, since the sizes are equal, that will be side 1x, side 2s, side 3s, side 4x, and that's 4x. And its area is x squared. That's the square of the size. The next one we are talking about is a parallelogram. A parallelogram is formed from two pair of parallel lines intersecting one another. Two pair of parallel lines intersecting one another, and that will give us that of our parallelogram. Now this will be the base. Look at the perpendicular height now. So this will be the base. This will be the base, and this is the height. And you see forming on the 90 degree. This is a parallel line. This is another parallel coming to intersect one another. And you have this angle as angle theta. Now moving around the object perimeter, A plus side B plus side A plus side B. Since just like your rectangle, these two sides are equal. These two sides are equal. So you have the perimeter as A plus B plus A plus B. And when that is added to A, then you have can't then factorize. You have 2 into bracket A plus B. Deliberately use A and B that will not see it as length and take it to be length as breadth. So its area is base, the base of that shape times its height. And from the diagram we saw earlier, I said this is the perpendicular line forming an 90 degree with this line, and that means this is the base. So we have A times H, and we substituted for that earlier that H can then be substituted for. That is what we did here to have H. H is equal to B sine theta. So substituting that for H, we have AB sine theta. That can also be done when you have an inclusive angle. An inclusive angle, I said, is an angle that formed from two lines. So the two sides are given. Size is the next shape we are considering now is our trapezium. Just one pair of parallel line and then the perpendicular height. So you have side A, side B, and then you have the perpendicular line. This is another side. This side can also be determined. And this side can be determined if we know the heights. Then we know this, we can then use our probably the angle here is given. Then you can use our trig ratio to determine this side based on what we have. You can also get that. So that will enable us to be able to get the perimeter, which is side 1 plus side 2 plus side 3 plus side 4. The area is now half AB, it's the parallel line, those two sides, AB times half A plus B into brackets H. And that will give us the formula for our trapezium. The next shape we are considering is our rhombus. For a rhombus, just like your square, all the sizes are equal. And we have this line, that's the diagonals. These diagonals will form angle 90 degree where they intersect. The point of intersection will give us angle 90 degree. And with that, we can come out with a right angle triangle, which will give us half this diagonal 1 and half diagonal 2 plus the side. So with this, we can do a lot of things. Half diagonal 1 and half diagonal 2. If the side is given and you are asked to determine one of the diagonals, you can just find out and use your Pythagoras theorem to solve that. And even if the angle is given, we can use that to determine of any of this half of the diagonal. And with that, we have the formula for the perimeter, which is moving around the object. So to move around that object, side 1 plus side 2 plus side 3 plus side 4. Side 1 plus side 2 plus side 3. So that's 4x. Then the area is now half diagonal 1, diagonal 2. I explained a little bit earlier that D1 and D2 are our diagonals. The next shape we have is a kite. A kite, you have 4 sides. These 2 sides are equal. And you have this line called the line of symmetry. The line of symmetry in a kite. And that's why when we're young, we tie our ropes and begin to make the kite to fly high. How do we get that? You can now determine that by finding side 1, that's the perimeter, side 1 plus side 2 plus side 3 plus side 4 to give us the perimeter of a kite. And the area, you divide the kites into shapes, known shapes. Find the area of those shapes, then divide them into known shapes, find the area of those shapes, and then add up. Divide your kite. You can divide. Take, for example, now I'm decided to divide this kite into 4 triangles. Find the area of this triangle, find the area of this triangle, find the area of this triangle, find the area of that triangle, then add the areas together to give me the area of my kite. Okay. The next shape we are considering now is our circle. Can you see? The center of the circle. And any point from the center of the circle to the circumference is called the radius. But when you have 2 of that, you have the diameter. So sometimes in a question, you'll be told to find the radius when you are given the diameter of a circle. So you divide by 2 to really obtain your radius. So in circle, you don't talk about perimeter, you talk about the circumference of the circle. That's actually moving around the circle, circumference. And the formula for that is 2 pi r. And pi is taken as 32/7. Sometimes 3.142 or 3.14 or 3.1 as the case, or as the instructor will give us. The area of a circle is pi r squared. The area of a circle is pi r squared. The next shape to be considered now is our sector. A sector. Then you have this, which is the length of the arc. So a sector is formed when 2 radii, can you see the 2 radii, the radius, then you cut out this part, which is angle theta. This is very, very important. I'm still going to make mention of this part being cut out, and that will lead us to finding the length of the arc, as I showed earlier, the length of the arc. A complete circle, the angle of a complete circle is 360 degrees. So if this part is cut out, that's the fraction. And that's why we have the length of an arc to be theta over 360, because theta is the part cut out of the circle, and the total sum of angle in a circle is 360 degrees. So theta is cut out times the length, which is the circumference of the circle. Can you see? Now the perimeter. Perimeter, we said earlier, perimeter is moving around the object. So the length of the arc plus the 2 radii. The length of the arc plus the 2 radii. And that's our perimeter. So perimeter is L plus 2 radii. We have a formula substituting theta over 360 degrees for 2 pi r. And you have this. Sometimes you can factorize. You have it 2r is diameter. You can have it 2r into bracket theta over 360 degrees pi plus 1, or diameter into theta over 360 degrees pi plus 1. The area, like I said, theta is the part cut out from the circle. So theta over 360 times the area of the circle. And that gives us the area of our perimeter. The next shape we are talking about here now is our segment. The segment actually is cutting off the triangle from our sector. Can you see the triangle? cut off this triangle, then you have your segment. So the segment is formed when the triangle is cut off from the sector. So when you cut out the triangle from the sector, you have your segment. So can you see? And this line is called the chord. It's not the diameter, but it cuts across, touches the circle, two parts on the circumference, but not up to the diameter. Diameter is cutting into two equal parts. So you have a triangle cut off from its sector to have your segment. So automatically, to get the perimeter, now will be what? Length of the arc plus length of the chord. Get our perimeter? Length of the arc plus length of the chord. Length of the arc plus length of the arc plus the length of the chord. You have this length of the arc, we know is theta over 2 pi r. Then the length of the chord can then be determined. You know, we are talking about the parts that is cut out. The part that is cut out. And what part is it that is cut out? Let's see the part that is cut out. Triangular form. So if we have this angle of a sector as theta, I can then use my cosine rule. Since this is the radius and the radius, I can then use my cosine rule to find this length. And cosine rule is r squared, since those sides are both radius, radii, r squared plus r squared minus 2r squared plus theta. That's not the only formula. I may decide to bisect this triangle into two equal parts. That means I'll be dividing the angle and I'll be dividing this side. So since I know the radius, I can use my trig ratio. I can use my trig ratio. I can use my trig ratio to have the angle. So I can then have it sine r, half r, so half a, represented by a, over this, and then I can get that. So well, I decided to use this one. So the area we said earlier that is cutting off. So we just subtract the area of the triangle from the area of the sector to have the area of our segment. Well, like I said earlier, these are the shapes we will be considering today. So with this, we